focus on the explanation. Oh, it's driving me nuts that there's such a glare there, but we'll have to kind of deal with it the best we can. All right, so I have broken this up so clearly. I have gone through question by question what you will expect. I will literally say this question will say this question will say that. I don't think I could be. Oh, also I picked every question from your homeworks, or questions exactly like those questions from your homework if I wanted to bulk it up. Lathan was asking before how many questions on it. I said, yes, the more the merrier, because I pick the easiest questions I can find and I put like a bunch of them on there to bulk up your grade. I probably shouldn't do that, but I do it anyway. I don't know why I'm too nice, right? So the hardest questions that are on here, there will only be one of each of those. The easiest questions, I just pulled every question like that I could find. The ones that go quickly and the ones that are really easy to solve, okay? I even point out which questions are super easy. Okay, so questions 1 through 4 will be very similar. They will all say something like this. How does the value of a in the function affect its graph compared to the parent function? Now, there are going to be 4 questions, so I gave you 4 examples of the types of questions you may see. These are 4 different functions, and it basically covers any type you might see in those 4 questions. The first thing that we want to make sure we understand is if we're going to be comparing these functions with the parent function, we need to know what that parent function is and what it looks like on a graph. So how do we know how these will compare? We're going to remember that a parent function looks like this. F of x equals x squared. Does the parent function ever change? No. The parent function always is f of x equals x squared. When the mommy and daddy have a baby, that's when we have to start comparing. How does the baby look a little bit different than the mommy and daddy? Where is it on the graph compared with the mommy and daddy? So these questions are going to require you to analyze the little babies in 2 ways. We need to say compared to the parent function, it may open up, it may open downward instead of upward. So for example, this guy, g of x equals 4x squared, it's going to open upward because why? Because a is positive. Now, on your quiz question, it might say something like, how is it different? If it says how is it different, then you're not going to say it opens upward, because that wouldn't be different than the parent function. The parent function opens upward, right? So be very careful. If you just need to say which direction it's opening, then go ahead and say that. But if it says, how is it different, then don't say it opens upward, because that would be the same as the parent function. Does that make sense?
Yeah.
So we're just, all I'm doing right now is analyzing the behavior of each of these functions. This is positive, so it opens upward. Let's continue on that trend and just look at the other functions. This is negative, so it opens downward. It's a sad parabola. This is, so it opens upward. This is negative, so it opens downward. So what I have here in these notes, does anybody want me to slow down for this? I'm gonna go back up here in a second. But let's go over how a graph changes. Wait. No. Okay, let's go over how a graph changes when A is not 1. Meaning there's some other coefficient, whether it's 2, -2, 0.5, -0.5, even -1 would be different. So here are the cases. The sign of A determines whether the parabola opens upward or downward, as we saw with these examples. Positive opens up, negative opens down. Only the sign determines the way it's facing, up or down. Only the sign determines that. Now, the absolute value of A is what determines the width of the parabola. And why do I say absolute value of A? It's because we don't care about the sign when we're talking about the width. It's all about the actual value, the absolute value of the digit, not the sign. The sign shows us up or down, the digit shows us wide or narrow compared to the parent function. So if the absolute value of A, or the digit with no sign, of A is greater than 1, like 2, 5, a billion, the graph is narrower. If the absolute value of A is a number that's in between 0 and 1, this is how we write it. 0 is less than the absolute value of A is less than 1. That's a crazy way of saying the absolute value of A, or the digit with no sign, of A is between 0 and 1. We call that a decimal number. The graph is going to be wider. It gets more spread out because the decimal number ends up, when it's multiplied by a decimal number, it ends up shrinking the value, which makes it go wider. If it's greater than 1 and you multiply by a number greater than 1, it makes the y values shoot up faster or down faster. Yeah? Yeah. So going back to these examples, right here. Let me just go back to these examples because I want to discuss why we name them narrower and wider. We just look at the absolute value, which is 4. It's bigger than 1, so it is narrower. This absolute value is also 4. It doesn't matter what the sign is. We're looking at just the absolute value of A, which is also greater than 1, 4, which is narrower. Now we've got 2 decimal numbers. Decimal numbers, numbers that are between 0 and 1, open up. I'm sorry, not open up. It does open upward, but these are both decimal numbers between 0 and 1, so they are going to be wider parabolas. Am I kind of in the way? Is that better? Trying to see if there's anything else I want to say about these specific things. Is there any question you have about this, or like you need help remembering a certain thing? Yeah?
What do you mean when you say like you don't include the negative with the absolute value?
So I was just kind of explaining why I wrote these inequalities with the absolute value of A instead of just writing A. Because if I just write A, and I have a negative 4 as A, that's gonna look like the number is less than 0. But that has, the fact that that number is negative has no effect on the width. The negative and positive only affects the direction. So we don't look at the sign, we just look at the number, which is what we call absolute value. So I was just kind of explaining why we use this weird symbol. It's because the absolute value is all we need to determine the width, not the sign. We just pretend the sign doesn't exist when we're determining the width.
They only matter for the height, or not the height,
The signs, yes, it only matters for the direction that it's opening up. Yep, that's the sign. Kariana, if you are choosing not to take notes, which I did announce was okay, I do need you to pay attention though, okay? You have to look at the board while we're working, okay? Yes? Yes? Okay. All right, let's go to the next one. Okay. All of those notes, but please stop me because I know I'm not because I'm not writing, I might accidentally go through this a little bit quicker than is healthy, so please make sure I don't go too fast. Okay, the good news is everything that I wrote here is something that will already be given to you, a completed, fully completed table of values. You don't have to solve anything on the table of values. For questions 5 and 6, you're going to be given a table of values that is already totally solved. You don't have to plug in and see what the output is. You don't have to do anything. This is done for you. It's going to show you the table of values, and then it's going to ask you a question that will require you to look at the table of values, specifically the behavior of the outputs, which we call the behavior of the function. The question that it's going to ask you is, over what interval is the function increasing? Over what interval is it decreasing? Now, to be honest, it's much easier to see the increase and the decrease if it's graphed and you can look at a picture. Because we know that a parabola, since it's symmetrical, it will increase and then get to the vertex and then decrease. Or it will decrease and then get to the vertex and then increase.
Can you go up a little bit?
Yeah. Like this?
Yeah.
So it really depends on if it's a happy parabola or a sad parabola, whether it's going to start by increasing and then decrease, or it's going to start by decreasing and then increase. But we know that since there's a vertex and an axis of symmetry, it's going to start one way, hit the vertex, and then go the other way, right? So we need to be able to see on the table of values if it's increasing or decreasing, and where it's increasing or decreasing. So, my instructions, I'll go back to the table in a second, but my instructions say, look on both sides of the vertex. Which section of the output values are increasing? So the question will ask for increasing first. It will say, over what interval is the function increasing? So if it wants to know increasing, all you have to do is look at your table, notice where your vertex is, which is the turning point, right? When you see that there's a value in between kind of like the mirror images, that's your vertex. This is where the behavior of the function is going to change. So either from here to the vertex it's going to increase, then from the vertex on it's going to decrease, or from here to the vertex it's going to decrease and then it's going to increase. We just have to see what is happening. So let's look for where it's increasing. It's also very tricky because we're dealing with, and I wish I could have used an easier example of this, but I wanted to give you an example of a table of values, something that you will see, because the table of values that it is going to give you negative numbers and decimals. So we really have to analyze the numbers and see, okay, are these numbers increasing towards a 0 or decreasing? To go from -2 to -0.5 to 0, are those outputs increasing or decreasing? They are increasing. Because a -2 is lower than this, and that's lower than 0, so from here to here, it's increasing. So we found the space where it's increasing. What kind of inputs are those? What kind of inputs are those? What kind of x values? Oh, yeah, x. What kind of x values are there in that space? Yeah, they're negative, which means, let's do something else. Which means the space where this function is increasing is on the negative side, on the x-axis. How would we represent that space or that interval with an inequality?
X is greater than 0. Oh, less than 0.
Yes, very good. So we would say that x is less than 0. The y values are increasing as we move closer to the vertex from that negative spot on the x-axis. And we can answer this question without even drawing a function. We can see the behavior because technically this function, if these are the negative values for x and then 0, this is kind of like a vertical x-axis. If you hold it like this is kind of like the origin, right? And then -2, -1, 0, 1, 2. So this is the negative side on the x-axis. This is the positive side. So this is the negative side and this is the positive side. And this is the space where it is increasing. We would say that interval is x is less than 0.
Could you go back to the other page?
Yep. We're also going to be asked the question, over what interval is it decreasing? So anytime you have a parabola, whatever your interval is for increasing, it's going to be the opposite interval for decreasing, because it's going to be the other side of the graph, other side of the coordinate plane. But let's just take a look and make sure we know what we're doing. Look at the portion of the table where the output values, or the y values, are decreasing. So we already said that this is the place where they're increasing. Then from the vertex, it's going from 0 down to -0.5. Then it goes even lower to -2. We can see how the function is decreasing. The y values are getting lower. So the parabola is decreasing. But where are they decreasing? What is the space or interval where they're decreasing? You can just name the type of numbers.
X is greater than...
Yeah, they're the positive x values, right? It decreases over the positive values of x. So we would say that it decreases where x is greater than 0, the positive values of the x.
Can you go back?
Yeah.
Go down.
This?
Yeah.
Is there anything about this graph that you guys find difficult to read? Personally, I find it difficult because of the negatives, because it looks like the numbers are because 2 is bigger than 0.5, so it looks like it's going down, right? But we have to remember that negative numbers or in the opposite direction.
Can you go down to where it says the question we're asking, what the question is, that part, like, it's on the page, it's just like, goes down, like, yeah.
Oh, I see what you're saying. Any other questions about this specific? Yeah.
Why does the have two negatives being multiplied? Why didn't it equal another negative?
Two negatives being multiplied?
I'm pretty sure.
I actually didn't multiply anything here. Are you talking about the table right here?
Yeah.
So the reason I wrote it like this without showing any work is because that's exactly what it's gonna look like. The computer or the status program does all the work in their head and they're just showing you the output. So here's your input and output. But I can tell you why all of these end up being negative. The reason is because when you square any number, whether it's positive or negative, you square it, it's gonna be positive. Because a negative number squared will be a negative times a negative, which will make it positive. After it's squared, it's being multiplied by this negative number, which will turn everything negative. Because you'll have a positive number being multiplied times a negative. All of your outputs are going to be negative. The parabola will literally be, if this is the vertex right here at 0, 0, it will literally be here, and every y value is going to be negative, except for the vertex y value, which is 0. It's almost negative, but it's not.
Can you go back to that?
Yeah. This?
Yeah.
Any other questions on this one? Do you think it's easier to understand when I already have the notes written out, or is it easier to understand when I write them out?
When you write them out.
Really? Do you want me to do that for the rest?
It feels like slower and less stressful. Cause
Okay.
we're trying to like get down the next thing you say, and then sometimes it's like when you move on, which is not your fault, you just move on and then we can't see it. And then,
Yeah.
and also like I feel like it's more like visual when you write it and
Yeah,
explain it.
because sometimes like you can't process it because it's like all there at
Yeah.
once. I know. I'm trying to find like what works best because I want you guys to be able to see everything. I feel like it might move slower when I'm writing and you're writing at the same time, but we can try that. Especially because, I mean, my goal here is to get through at least half of this. Are you okay with watching the rest of this on?
How many
You-
questions are there?
There are 20 questions, but we're already on question 7. So I will definitely be able to get through the next couple of questions. But I can write it out if that's easier. I'm just gonna do it on graph paper. Okay,
This is just question 7 alone.
so this will be questions 7 and 8. They will be the same type of question, but I'm gonna give you 2 examples, one for 7 and one for 8. I just don't know if like the book will like switch them. It's gonna ask you the same thing, but the functions will be different. So for questions 7 and 8, just know that what I write here is going to be like the summarized version. I'm gonna write and talk, but on Canvas you have like all of the notes, okay? So for 7 and 8, it's gonna give you functions, and it's gonna ask for your vertex and axis of symmetry. So here's an example of a function it might give you. It's going to ask you for the vertex, and it's gonna ask you for the axis of symmetry. So now we have a function that has the parent function right here, but then 7 is being added to it. How does that change the parent function? Yes? Yeah, it shifts vertically. So adding or subtracting to the parent function shifts it vertically. Vertical shift.
And that's K, right?
Yes, very
I think I
good.
got it.
This is the same thing as x squared plus k. And remember, K means keep that sign. So if it says plus 7, it goes up 7. K means keep the sign. So plus 7 means up 7. Does that make sense? Now, if we're gonna write the vertex, we need an entire coordinate pair. We need an x value and a y value. Yeah.
It's 0, 7, right?
Very good. Yeah, the x value is gonna be 0 because
Anybody do that, bro?
if the parent function,
Jacob, you're my kid.
hello. If the parent function is it has the vertex right here at the origin, which it does, a vertical shift is going to keep that x value remaining at 0 because it's not shifting left or right, it's only shifting upwards. So the x value will still be 0, the y value will be 7. Then we need the axis of symmetry.
I got it.
Oh, whoops. Did I not? Oh, I don't think I wrote that.
I got it.
I don't think I wrote on the notes and might have to.
I got it.
Upward. Okay, I did not include that. All right, I'll have to make a note. Okay, tell me what the axis of symmetry would look like. Yes.
X equals 0.
X equals 0. Very good. All right, make sure you get those notes down because I'm probably not going to do it online. Okay, the axis of symmetry would be x equals 0, the exact same axis of symmetry as the parent function, because it's a vertical shift. Just goes up.
I did that. I really hate that.
All right,
Wait, what?
the axis of symmetry. So for a parent function, the axis of symmetry would be the y-axis, right, which is x equals 0. If the graph shifts upward, but doesn't go left or right, then the axis of symmetry is going to be the same thing. X equals 0. That make sense? Okay. All right. So the other example you're going to get on 7 and 8, this is probably going to be like number 8, would be g of x equals x minus 40 squared. Now notice something very different is happening here. The numbers being added or subtracted to the
X.
value, the input value. It's not being added to the output, that would be k. If it's being added to the input, that means that it's the h value. So that would be a horizontal shift. Now this is the tricky one. Yeah.
I got it. 40, 0.
Very good. The
Exactly.
vertex
You're not smart, be quiet.
would be, it's not helpful, 40, 0, because if it shifts horizontally, now remember, H means get that sign, what?
The heck out of here.
That's not what you said.
That's what I said.
That's kind of funny. Get that sign the heck out of here. I don't know how anybody else in math remembers that. This is the only way that I remember to change the sign. Get that sign the heck out of here. So if this says negative 40, my shift is actually going to be positive 40. So it's going to go to the right. To the right 40 units. A shift to the right is going to radically change the axis of symmetry. And just like Cobb said, that axis of symmetry is going to be like all the way probably down here. Oh no, you didn't say the axis of symmetry, you said the vertex. The vertex is going to be at 40, 0. Yes, very good. And the axis of symmetry.
So is axis of symmetry just whatever the x value is?
The x value of the vertex. Yeah, very good. Let's write that.
X equals 40.
The,
equals 40.
X equals
whoops.
40.
The axis of symmetry is whatever the x value of the vertex is. And we talk a little bit more about that idea in the later problems, but we can definitely fill it in here as well. Do you think these notes will be helpful tomorrow?
Yes.
One person
What?
thinks.
Is that says whatever?
Yeah, whatever. Whoops. Online, you'll see, like on Canvas, you'll see like I wrote a summary of what it means when K is being added to the output, what it means when H is being subtracted to the input. It has all of these notes if you want just like a summary of it in your notes. Okay. We have plenty of time. We're gonna do questions 9 through 12. 9, 10, 11, and 12 are going to be all the same process. So I'm only gonna do one example, and then you do that process for 9, 10, 11, and 12. It's a simple process, so let's go through it. You know it for number 9, you'll know it for the rest. So 9 through 12 is going to say, identify the vertex, axis of symmetry, the direction of the graph, and whether it's narrower or wider than the parent function. Those are the 4 things it's going to ask you for. Then it's going to give you a function that looks something like this. And I just like changed the numbers slightly. Now here is where we're given the function in complete vertex form, where we are given our H and our K. So we have our H here.
Our H and our K just stand for X and Y, right?
They stand for the X and Y of the vertex, yes. But remember, so we can do our vertex right now, but just be very careful because the H stands for get that sign the heck out of here. So what's the X value of the vertex? -2. And what is my Y value of the vertex?
Positive 5.
+5. K for keep that sign. Kariana, pay attention. Okay. All right, so then, where are we? Okay, so we did our vertex, and now we need to locate the axis of symmetry. And as we just pointed out, the axis of symmetry is the same thing as the
X value.
the x value of the vertex. So it's just x equals -2. How easy is that? Now the direction of the graph and the narrower or wider is so easy to do. We already did this in examples in questions 1 through 4. What direction is it facing? Up or down? Does it open up or down?
Down.
Oh,
Wait,
because
I
it's
mean
narrow.
up, I mean up.
How do we know?
Because it's positive.
Yeah, because the A value is positive. And don't forget, we have A, this is like, oops, should say
Why
minus
do you need to feel like that, dog?
-8² +k. So that's the vertex form. A is this number outside of the parentheses. It's positive, so the graph opens upward. And is it narrower or wider than the parent function? How can we tell?
The negative.
Nope,
If
not
it's
from the
greater
sign.
than
Yeah, but if the
or less
absolute
than
value is
narrower.
greater than 1 or
Less than-
or a decimal number, like between 0 and 1. This one is greater than 1, so it's narrower. Very good. And that's always one that I have to think about. If it's greater than 1, is it, which one is it? It's narrower, because it shoots really fast.
Wait,
Okay,
for like when you have the entire thing, like, how do you find out again? If it's
so when you have the entire form, which you'll have in your notes, it's also up there on the wall, your A value is the number that's your first number that you see. It's the number right outside of the parentheses. If that number is greater, the absolute value of that number is greater than 1, it's narrower, skinnier. If it's between 0 and 1, a decimal number, it is wider. Now, we just solved this entire problem in just like 2 minutes. And then you'll have to do that exact same thing for 10, 11, and 12. But they'll give you a different function. So they might give you a negative number for A, and then it will go downward. It might give you a decimal number, and then it will be wider. And of course, it'll give you different numbers for your vertex. But you guys can handle it, right? As long as the process is the same, you can do it. And I have much prettier notes on Canvas that you are welcome to copy down as much as you want. All right. Do you guys want to pack up? I'm gonna start with 13 through 20 in my next class. So I'll have that. When you guys watch the video, you'll start from the beginning of period 7